Welcome, ladies and gentlemen. So what I like to do is show you how to find the inverse of a function. And basically, there's kind of like some step-by-step process that we really go through when finding the inverse of a function, basically informally. So what we're looking into doing, or basically the process that we're going to do, is we're going to replace f of x in with y. Okay? So the first thing we're going to do, and you don't have to do this, but this really just kind of makes things a lot simpler, especially when you start dealing with functions that are going to have quite a bit of operations. So the first thing I do is I replace f of x in with y. That's like the first step. And you could do this for all these problems. And everybody can do it. It's really like, OK, got that. The next step is basically going to be to swap your x and your y. Because remember, when we looked at like the graphs of a function and its inverse, right, they're reflected about the x equals y axis. So therefore, they're going to be kind of like a reflection. So we're going to swap the x and the y's, which would basically be the same thing if you looked at it graphically. So now I'm going to have x equals y. Oh, actually, I was going to try to do a different color for each step. So let's use green on this one. So therefore, I write x equals y plus 3. OK, so now that we got x equals y plus 3, now the last step is going to be to solve, or not the, well, kind of the last step, is to solve for y. So you can see now we have to use our inverse operations to solve for y. So I'm going to subtract a 3 on both sides. And I have x minus 3 now equals y. And then to finish off our problem, basically now what we're going to do is go back and replace y. Because again, we kind of only use that y to really kind of help. Because we would rather swap x and y's rather than x and f of x's. So now we're going to rewrite it. We're going to want to rewrite it with the f of x first. But now we're going to use our inverse notation. So my final answer is going to be f inverse of x equals x minus 3. And again, the f inverse of x, that is not a negative exponent. That is just our inverse notation. OK? So there's kind of like the first example broken down step by step for you. I'm going to kind of work through everything a little bit quicker. I'll still talk about it. But you know, I'm not going to break it down each and every step here, because I will do each and every step so you see it. But I'm just not going to like use a different color and that kind of stuff. All right, so over here, I'm going to have y equals 2x. Swap the x and y's. Now solve for y. OK, so therefore now I will replace that. So those divide out. So I have f inverse of x equals x divided by 2. OK, let's go over to the next example here. Replace f of x equals y. So then that becomes negative 3x minus 1. Swap the x and the y's. X equals negative 3y minus 1. Now I need to solve for y. So the first thing I'm going to do is I'm going to add a 1 to both sides. So I have x plus 1 equals a negative 3y. Then divide by negative 3. Divide by negative 3. So then I have f inverse of x equals x plus 1 divided by negative 3. Or you can just put the negative in front. So I'll write the negative in front. Or you can just keep it in the denominator. That's perfectly fine as well. OK, all right, so now let's go into x cubed. We're getting into these different functions, right? So I have x cubed minus 2. Well, again, we're going to do the same thing. Y equals x cubed minus 2. Swap the x and the y's. So I have x equals y cubed minus 2. Now to solve for y, the first thing we want to do is undo addition and subtraction first. So I have x plus 2 equals y cubed. Now we need to undo taking the cube, or raising a variable to the third power. So to undo that, I'm going to take the cube root of both sides. So therefore, my final answer is f inverse of x equals the cube root of x plus 2. OK, now let's go and get into the next one. Again, we'll rewrite y equals x plus 5 squared. Swap the x and the y's. OK, now see here we undid addition, we undid subtraction, right? Well, now you can see that the addition is inside the squaring. So I have to undo squaring first. So to undo squaring, I need to take the square root of both sides. So therefore, I have the square root of x equals y plus 5. And then now to solve for y, I subtract the 5. I cannot subtract there. So my final answer is f inverse of negative x equals the square root of x minus 5. OK, last example here. So I have f of x equals 1 over x. Replace f of x with y. Swap. OK, now solve. Now, a lot of students get confused. Whenever you have a denominator, whenever you have a variable in the denominator you're trying to solve for, just multiply by the reciprocal. So therefore, I have yx equals 1. Then to solve for y, I need to divide by x. And I have y equals 1 over x. Hey, look at it. That's itself is its inverse. So I have f inverse of x equals 1 over x. So there you go, ladies and gentlemen. That is how you find the inverse of a function. Thanks.